What is up, guys? Gunda Math over here, and this is a continuation of the MIT 2020 qualification exam. This time it's going to be problems 6 through 10. Let's get started with the first integral. And then this is an indefinite process. So we have a bunch of nested square roots. So our first thing we want to do is we want to expand this a little. So we realize this is x to the power 1/2, then x to the power 1/4, and then so on, so on. So, and then when we're just multiplying a bunch of exponents, all you do is add the power. So in reality, this is just x to the power 1/2 plus 1/4, plus 1/8, and then plus indefinitely. So now we can use the formula for the sum of the infinite geometric sequence. So we know that the sum is a sub 1, which is our 1/2, over 1 minus our common ratio, which is 1/2. This is equal to 1/2 over 1/2, which is equal to 1. So it's just the integral of x. This is equal to, of course, x squared over 2 plus some constant of integration c. Next question. Actually, yeah, but whatever. Okay, this is like a trigonometric one. This is sine to the power 4x, cosine to the power 4x, cosine of x plus sine of x, cosine of x minus sine of x dx. Okay, I immediately noticed that cosine of x plus sine of x times cosine of x minus sine of x is equal to cosine of 2x. Okay, so we can rewrite this as the integral of sine 4x, cosine 4x, cosine 2x dx. Now sine 4x, cosine 4x, this actually kind of reminds me of the double angle formula for sine. Namely, we know that sine of 2x is equal to 2 sine of x cosine of x. So if we raise sine 2x to the power 4, we get sine 4 2x is equal to 16 sine 4x cosine 4x. Or in other words, we have sine to the power 4x, sine to the power 4 2x over 16 is equal to sine to the power sine to the power 4x cosine to the power 4x. So we can rewrite this integral to divided by 16. We take out the 1 over 16 out of there, and then we get sine to the power 4 2x and then cosine 2x dx. So now obviously this is just an easy u substitution. We just let sine 2x equal u. So by the chain rule of differentiation, we get 2 times the cosine of 2x dx is equal to du. Or we have cosine 2x dx is equal to du over 2. Du over 2. Okay, so this becomes 1 over 32, the integral of oh my god, brain freeze. Okay, u to the power 4 du. This should be it. Okay, so we have u to the power 5. What is our u? So we have sine to the power 5 of 2x over 160 plus c. I think, yeah. Again, I haven't really done these problems, so I don't know if they're correct or not. Now this is the next problem. This is ln of x squared plus 1 dx. So how can we attempt to solve this? Well, I mean, if we had an x dx term, we can easily just let x squared plus 1 equal u and then be simple u substitution, but we don't have that case. We know from prior experience, if we have a single term, specifically ln, we want to do, essentially all we want to do is by parts. So 1 times ln of x squared plus 1. So let ln x squared plus 1 be the function we want to differentiate and 1 be the function we want to integrate. Okay, so this becomes, upon evaluating, this becomes x ln of x squared plus 1 minus the integration of differentiation of ln x squared plus 1. That's 1 over x squared plus 1 times 2x. So in other words, that's 2x over x squared plus 1 times, of course, the integration of 1, which is x. Okay, this becomes x ln x squared plus 1 minus integration of 2. Let me just bring that over for you. 2x squared over x squared plus 1, right? Okay, I see a clear path. This becomes x ln x squared plus 1 minus, we bring out the constant, which is 2 times x squared over x squared plus 1. Now again, there's no really easy way to integrate this, so what we need to do is we need to add 1, subtract 1. So we have plus 1 minus 1, so this becomes x ln x squared plus 1 minus 2 times the integral of 1 minus the integral of 1 over x squared plus 1. So this becomes x ln of x squared plus 1 minus 2 times x, the integral of 1 over x squared plus 1 is arctan of x. Okay, so now what we have is we have x ln, and then we have minus 2x minus 2 arctan of x plus c. Let me bring up the next integral. Our next integral is from 0 to 2 pi of cosine of 2020 power x dx. Now a key formula from this, if we have the integral from 0 to 2 pi of cosine to the power of nx dx, I believe that the reduction formula for this would be n choose n over 2 cosine, it's 2 to the power 1 minus n pi. Again, just try to derive the formula for cosine, the integral for cosine of nx, and then try to derive this. I'll probably do that in a future video. So next, all we have to do is plug in. So we get 2020 choose 1010 2 to the power of minus 2019 pi. And finally, for our last question, it is the integral. Okay, so the integral of 2x plus 1 over 2x squared plus 2x plus 1 dx. Now we realize that the differentiation of the denominator, if you find the derivative of 2x squared plus 2x plus 1, we get 4x plus 2. 4x plus 2, that's just twice this denominator, so we think to 1/2, and then just immediately repent it by doing this. Yep. Yeah. Okay, from now, all we realize is that the differentiation of the denominator is indeed the numerator. So it's just 1/2 dx du over u. 1/2 ln of 2x squared plus 2x plus 1 plus c. So those are integration problems 6 to 10. I hope you enjoyed this video, and until next time, see you.